G'day, so this video we are going to be looking at an application question within trigonometric equations or circular functions. So we'll just get into how we break these down and some key things that we need to look at. So the temperature in degrees Celsius in a town over a day is modelled with the function. So this is the rule that it's modelled by. Okay, so where T is the time in hours after midnight. So it can go from 0 to 24. The amount of hours in a day. So we'll get into A, what's the temperature at midnight? So the temperature at midnight here, so we just need to work out what's our small value of T. So at midnight, how many hours have passed? That's 0. So what we need to do is substitute T is equal to 0 into our question. So then so our temperature is going to be equal to 17, and it's going to be minus 8 cosine 0. So we actually don't even need a calculator for this one, hopefully. So 17 minus 8, and cosine of 0 is actually 1. So it's 8 times 1. So 17 minus 8, this gives us 9 degrees Celsius at midnight. So that's how you work out part A. So B. What's our max and min temperatures reached? Because this is a trigonometric equation or a circular function, you know there's going to be max and min points on our graph, if you can think about it graphically. And this relates to our amplitude. So we just need to work first out our amplitude. And just remember, this is what's multiplied. So your cosine or sine function. So in this one, it's 8. So our amplitude is the magnitude of 8. So that just means it's going to be positive 8. So that's our amplitude. So now we can see how far up and down this graph's gone, modelled by this 17 here. Okay, I'll just get rid of all this highlight. So modelled by that 17 there, this is how far up the graph's gone. So it's up at 17, that's the middle point. Our amplitude's 8, so we can actually write this out. So our max is going to equal 17 plus 8. This here is equal to 25 degrees. And our min is just going to be 17 minus 8. So you don't even need a calculator to work out this one either. Alright, so part C. This is one where it does get a little bit trickier, but these types of questions you will probably have access to your calculator to work all these out. So what times of the day to the nearest minute are temperatures warmer than 20 degrees Celsius? Okay, so what we need to do here is we need to think about this graphically, and I've got this up in the top corner here, hopefully you can see. We've got our two graphs. We've got 17 is equal to 8 cos pi x over 12 from 0 to 24 in the blue, and in the red we've got f of x is equal to 20, so when the temperature is equal to 20. So what we actually need to do here is work out these times that it's equal to 20, and you can see I've done this here. Alright, I've used the intersection on our CAS to work this out. Okay, you can also use the solve function on your CAS, so you could use the solve function if you have 20 is equal to 17, our function, minus 8 cosine pi t on 20. Just be aware on CAS that you need to have it in x when you're graphing. Okay, so you could solve for that, and that could work out both times as long as you set your domain. Alright, all of this here is essentially equal to 7.47, and I've just got my answers up the top here that I've done on my CAS by working out the intersection. and our other answer is 16.5. Okay, so they're our time periods. Now we need to work out when in our day this is. So this is 7 hours 47 after midnight. So this is 7:28 because we need it in time. So that's 7.47. So this is 7:28. And then it's going to be 2 because it's when it's all above this area. So all of this is above it and no one else or nowhere else. So it's going to be 2, that's 1650, which is, you can write as in 24-hour time, it's normally better to write 16:30. Or you can write 7:28 a.m. to 4:30 p.m., etc. like that. So either or would do there. So finally, we go look at part D. Sketch the graph for the temperatures over the day. So with this, just make sure that you work out your period. I'm not going to go through this. You've got an example up the top here of what it does look like. But you're working out your period, and this is our 2 pi to pi over b, and our b value for this is equal to pi over 12. So our period's actually going to equal to 24. And you can see this in the graph there. Okay, starts here, finishes at the same spot in the one period, Okay, so our period's equal to 24. Our amplitude, we've already worked that out, is equal to 8. And sort of our starting point here, or our middle point, so where the average value is, this is going to be at 17. So our midpoint or average. So this is sort of like the middle part. So it's been translated up 17. Okay, from the x-axis. So just be aware, we also have this here, and this is what gets most people. It's minus 8 cos. Because our normal cosine graphs, we start at the top and go down. So because it's minus cos, we start from bottom. And go up. Okay, so that's just slightly different from your normal cosine function or your positive cosine function. Okay, so that's just something to look out for there. So you can see this, we've started from the bottom here and then we've gone up. Okay, so hopefully this helps with application questions and you can break these down and solve these. Yet again, it's just about understanding the words, breaking that down into your actual question. What does this mean? So midnight means that no time's passed. Maximum and minimum temperatures, this is the tops and the bottoms of our graph, and so forth. And it's just breaking down these facts. So good luck with this, and